Welcome to Pixel Perfect, the image sensor podcast. Join host Manu and image expert Emma.
Welcome back, everyone, to Pixel Perfect, our deep dive into the world of image sensors and camera modules. I'm Manu, and as always, I'm joined by Emma.
Hey, everyone. It's great to be back with you for episode 3.
Now, in our past couple deep dives, we've been exploring the fascinating world of image sensors, those tiny chips that capture the light and transform it into the images we see.
Right.
We even talked about how those sensors are assembled into camera modules. But here at Camemake, we don't just build any camera module. We actually specialize in crafting custom solutions to meet the unique needs of each customer.
Yeah, exactly.
So, Emma, how does this custom journey actually begin? What's the first step when a customer comes to Camemake with an idea for a custom camera module?
Well, it all starts with a conversation, really. We sit down with a customer and we really try to understand their vision. What are their goals? What challenges are they facing?
So it's like a brainstorming session where you're exploring the possibilities together.
Yeah, absolutely. It's a really collaborative process.
Yeah.
We ask a lot of questions to get a really clear picture of what the project needs.
So what are some of those key questions that you ask?
Well, one of the first things we want to know is, what's the purpose of this camera module?
Yeah.
Is it going to be used for security, medical imaging, maybe it's for a smart home device, or something completely different?
Right, because I imagine a camera designed for a self-driving car would have very different requirements than, say, a camera used in a medical endoscope.
Exactly. The environment that the camera will be operating in is super important too. Will it be indoors, outdoors?
Does it mean to be weatherproof?
Exactly.
Yeah.
Waterproof, dustproof, resistant to extreme temperatures, all those factors come into play early on.
It makes you realize how much thought actually goes into even the simplest cameras.
Yeah.
I never really considered that my doorbell camera needs to be weatherproof, but of course it makes sense.
Oh, yeah, absolutely.
It's exposed to the elements all the time.
Right. Then we dive into the performance requirements. What resolution do we need? How fast does the camera need to be?
Right, and I know low-light performance is often a big concern as well.
Oh, absolutely, especially for security cameras or anything operating in dim lighting. And then, of course, we need to think about how the camera module will be integrated into the customer's system.
Yeah, the size constraints, the connectors, how it'll communicate with the other devices.
Exactly. It's all about making sure that this camera module fits seamlessly into their overall design.
So it sounds like this initial phase is really about gathering all the information, asking the right questions, and translating that initial vision into more tangible requirements.
Yeah, that's a great way to put it. It's like laying the foundation for a house. You need a solid plan before you can start building.
Makes sense. So once you have a good understanding of the customer's needs, what's next?
Well, that's when we start turning that vision into reality. We start working on those concrete technical specifications, choosing the right image sensor, the lens, the PCB.
All the nitty-gritty details.
Exactly. That's where it starts to get really interesting.
All right, well, let's dive into those details then. How do you actually go from a customer's vision to choosing the perfect components for their custom camera module?
Well, that's a great question. And it's something we'll definitely cover in our next deep dive.
Sounds good to me. We'll be right back after a short break.
See you soon.
Don't go anywhere. We'll be back with more Pixel Perfect in just a moment.
Taking a moment to remind you, if you're inspired by what you're hearing and want to learn more about how Camemake can help bring your imaging projects to life, head over to camemake.com.
So before the break, we were talking about how Camemake takes a customer's vision for a custom camera module and turns it into reality. Emma, you mentioned that the next step is choosing the right components.
Yeah, exactly.
So let's break that down a bit. What are the key components that go into a camera module?
Well, the heart of any camera module is the image sensor. That's the component that captures the light and converts it into an electrical signal, which is then processed to create the image.
Right, and I know there are different types of image sensors out there.
You're absolutely right. The two most common types are CMOS and CCD sensors.
So how do you decide which type of sensor is best for a particular application?
Well, it really depends on the specific requirements of the project. CMOS sensors are generally known for their speed and low power consumption, so they're often a good choice for applications like high-speed video or mobile devices.
Makes sense.
CCD sensors, on the other hand, are known for their higher image quality and sensitivity, so they might be a better choice for applications where image fidelity is paramount, like medical imaging or scientific research.
So it's a trade-off between speed and power consumption versus image quality.
Exactly. And of course, there are a lot of other factors to consider when choosing an image sensor, like resolution, frame rate, and pixel size.
Okay, so let's say you've selected the perfect image sensor for the job.
Okay.
What's next?
Well, then we need to choose the right lens to go with it.
Right, because the lens is what focuses the light onto the sensor.
Exactly. And just like with image sensors, there is a wide range of lenses to choose from.
I remember you mentioned fixed focus and autofocus lenses in a previous deep dive.
Yeah, those are two common types. Fixed focus lenses are simpler and more cost-effective. They're a good choice for applications where the distance between the camera and the subject is always going to be roughly the same.
Like a security camera monitoring a hallway.
Exactly.
But if you need to be able to focus on objects at different distances, then an autofocus lens is necessary.
Right. And then you have all sorts of specialty lenses as well.
Like what?
Like wide-angle lenses for capturing a wider field of view, telephoto lenses for zooming in on distant objects, macro lenses for extreme close-ups.
So many options.
Yeah, the lens really plays a crucial role in shaping the overall image. It's like choosing the right pair of glasses to see the world in a particular way.
And speaking of seeing the world in a particular way, you mentioned earlier that Camemake sometimes integrates hyperspectral technology into camera modules.
We do.
What exactly is hyperspectral imaging?
It's a type of imaging that captures information from across the electromagnetic spectrum, not just the visible light that we see with our eyes.
So it's like giving the camera a superpower.
Exactly. It allows us to see things that would otherwise be invisible.
That's amazing. What are some of the applications of hyperspectral imaging?
Oh, it's used in a wide range of fields.
Yeah.
From agriculture to medicine to environmental monitoring.
Wow. So we've got the image sensor and the lens figured out.
Right.
What's the next piece of the puzzle?
The printed circuit board, or PCB.
The PCB. That's the board that all the electronic components are mounted on.
Exactly. It's like the foundation of the camera module.
And are there different types of PCBs?
There are. We have rigid PCBs, which are more durable and better for fixed installations, and flexible PCBs, which are more adaptable and can be used in applications where the camera needs to bend or flex.
So you're really taking into account not just the technical specifications of the components, but also the physical environment where the camera module will be used.
Oh, absolutely.
So we've talked about the image sensor, the lens, and the PCB.
Right.
Are there any other key components that we're missing?
Well, sometimes we might add filters to block certain wavelengths of light, or coatings to improve the durability of the module.
Like adding those final touches to make sure everything is perfect.
Exactly.
So once you've chosen all the components and designed the PCB,
yeah.
What happens next?
Well, then it's time to build a prototype and start testing.
Okay, so let's talk about that process. How do you go from a design on paper to a physical camera module that you can actually test?
Well, that's a great question, and it's a topic that deserves its own deep dive. So I think we'll save that conversation for our next episode.
Sounds good to me. We'll be right back after a short break to delve into the exciting world of prototyping and testing.
Taking a moment to remind you, if you're inspired by what you're hearing and want to learn more about how Camemake can help bring your imaging projects to life, head over to camemake.com.
So before the break, we were talking about how Camemake transforms those custom camera module designs into physical prototypes.
Yeah, it's where the design really starts to come to life.
So walk us through that process. What happens once you have all the components and the PCB design finalized? Well, the first step is to actually build a prototype of the camera module. You know, it's where we get to see our digital blueprint become a real, tangible device.
That's got to be exciting.
Oh, it's always a thrill.
So how do you actually go about building a prototype? Is it a mini version of your mass production process?
It's similar in some ways, yeah. We use the same advanced SMT production lines to assemble the prototypes.
SMT.
Surface mount technology. It's a highly automated process.
So tiny robots carefully placing each component onto the PCB.
Exactly. With incredible precision.
I can only imagine how delicate that process must be.
Oh, it is. Even a tiny speck of dust could cause problems.
That's why you build the prototypes in those clean rooms, right?
Exactly. Those clean rooms are like giant air purifiers. They filter out all those tiny particles that could contaminate the modules.
So you're really pampering these prototypes.
Well, we want to make sure they're built in a pristine environment.
Makes sense. So once the prototype is assembled, what happens next?
Then comes the fun part, testing.
Okay, so what kind of tests do you put these prototypes through?
Well, we want to make sure these modules can handle anything the real world throws at them.
So you put them through the ringer?
We do. First, we check the image quality, the resolution.
Make sure those images are crystal clear.
Exactly. And then we move on to environmental durability tests.
So extreme temperatures, humidity.
Oh, we expose those prototypes to all sorts of conditions, vibration, shock, you name it.
If it's going to be used outdoors, you probably freeze it, bake it.
We do.
Wow, tough crowd.
We also do compatibility testing.
Compatibility?
Yeah, making sure the camera module communicates properly with the customer system.
So it plays nicely with all the other components.
Exactly.
So this prototyping and testing phase sounds pretty rigorous.
It is. But it's all about fine-tuning and perfecting the design.
And I imagine it's an iterative process.
Oh, absolutely. We gather feedback from the tests, refine the design, build a new prototype, test again. We keep going until the camera module hits all the performance benchmarks.
So you're constantly improving, making sure it meets the customer's exact needs.
Exactly. That's what custom design is all about.
Well, Emma, it's been fascinating getting this behind-the-scenes look at how Camemake designs and builds custom camera modules.
It's been my pleasure.
And for our listeners, we hope you've enjoyed this deep dive into the world of custom camera technology. Be sure to join us next time as we continue to explore the fascinating world of image sensors. Until then, happy snapping.